we have finished this index properties of soil chapter, and we'll see the some of the formulas in this chapter. So initially we have derived all the relationship between the solid air and water relationship. So that's what we have get all the expressions from this, and we'll have to make it through with these all expression. And one more thing I'd like to highlight upon this session is that even if you go on internet and you find out the competitive examination paper, any UPSC, MPSC related to a civil engineering, you will not find a question paper without the question from this area. That means any paper, the question from this area has to be there. So this particular index properties of soil has got a very important formulation and as well as very important role in this competitive examination. And this particular thing may be asked for 4 to 6 marks in the gate as well. So, and one more thing, that before going into the next chapter, you must have the knowledge of all this, and you must know all this relationship in detail, so that you just need to put up the formula and get the answer, because all these things are linked to the next chapters. So we'll go for a quick review session for the all formulas. First of all, we have seen this expression between the void ratio, degree of saturation, water content, and the specific gravity of soil solids, that is E into SR equals to W into G. Then we have seen the relationship and definitions of the bulk unit weight. We have seen the definition of dry unit weight. We have seen definition of saturated unit weight. We have seen a definition of unit weight of soil solids, and also one more definition of unit weight, which is a submerged unit weight, which is also denoted by gamma dash or also gamma submerged, you can write, which is nothing but when the soil has got submerged into the water, then its unit weight has got reduced from its saturated by an amount equals to the unit weight of the medium in which the soil is been submerged. So therefore, in almost all the practical cases, the fluid at which the soil is getting submerged is water. So therefore, submerged unit weight of a soil, we take it as gamma submerged, which is nothing but gamma saturated minus gamma of water. And if I go with the all formulation, I know bulk unit weight, the ratio of bulk unit weight to the unit weight of water is G plus E into SR divided by 1 plus E. And this in turn again is equal to, if you take G common, it becomes 1 plus W divided by 1 plus E. So this is the another second equation. Right. And if I just place the degree of saturation equals to 1, then the soil becomes fully saturated, and bulk unit weight is then replaced by saturated unit weight. So saturated unit weight then now becomes G plus E divided by 1 plus E into gamma W. And if I just deduct this saturated unit weight in with the unit weight of water, we'll get the expression of submerged unit weight, that is gamma dash. So gamma dash becomes G plus E divided by 1 plus E minus 1 into gamma W. So if I solve this, you will end up at this expression. Gamma dash becomes G plus E minus 1 minus E, that means minus 1 plus E minus E will get cancelled. It becomes gamma dash into G minus 1 divided by 1 plus E into gamma W. So this is the relationship for the submerged unit weight G, E and the gamma W. So remember, this is very again important. So and also we have also seen this expression when you have the degree of saturation equals to 0, that means the soil is totally dry. So for dry soil, we have seen gamma D equals to, if you plate just the SR equal to 0 in this equation, you will get G divided by 1 plus E into gamma W, so on and so forth. And also you have also seen the definition of gamma D, which is equals to 1 minus Na G into gamma W divided by 1 plus W into G. This expression also we have seen, and also we have seen the relationship between the void ratio and the porosity, because in many times in all competitive examination this is very important formula, which is nothing but the relationship between void ratio and the porosity. This is very important, because in many cases you need to convert N from E and E from N. This is also expression number 6. Along with all these equations, we have also seen the bulk unit weight is nothing but the dry unit weight into 1 plus W. This also we have seen. And remember, in all cases the hierarchy, that means in terms of quantitative way, the highest value is of the gamma S, then it is followed by gamma saturated, then it is followed by gamma bulk, then it is followed by gamma dry, and in the last you have submerged unit weight. So that's the this is the hierarchy for all the unit weights of the soil. So this is also again very important as far as competitive examination is concerned. So in terms of the numbers. So in this we go for the problem session. So for A's, I have divided this problem into 3 levels: level 1, level 2 and level 3. So in level 1 we have 3 problems named as 1.1, 1.2 and 1.3. In level 2 we have 5 problems: 2.1, 2.2, 2.3, 2.4 and 2.5. And in level 3 we have 3 problems: 3.1, 3.2, 3.3. But you see, the level 1 is easiest, level 2 becomes tougher, and level 3 becomes much more tougher. So again, apart from these, we have 2 different problems named as capital A and capital B. The capital A problem is based on sand replacement method. And the another problem, there's B, which is apart from all these levels, is based on the shrinkage limit test. So we'll go quickly for the problems. So the problem statement for the level 1 problem is as follows. So we have 1 m cube of wet soil which weighs 20 kilonewton, and its dry weight, when it is dried, then it becomes 18 kilonewton, and the specific gravity of solid is given it as 2.67. And in this question, what is being asked is water content, porosity, void ratio, degree of saturation, and also they have asked to draw the phase diagram. Maybe in first case, this is very quite a conventional problem and very easy. So what initially we will do, we'll draw a phase diagram. So initially you have the wet soil. What is the meaning of wet soil? Wet soil means it has water in it, it has a water content in it. So this is the solid part, this is water part, and this is the air part. So that's how it mean by the wet soil. So whatever water plus solid, so for all practical purposes, I told you the weight of air, we'll take it at the 0. So for all practical purposes, we'll take the weight of air as 0. In this condition, we call it as a natural condition of soil. And here, once you dry it in the oven, then water will be going out of its volume and only there will be a solid. So since after oven drying you are just evaporating a water, solid volume has to remain as it is along with weight, because that's what we seen that the solid are incompressible, right? And also we didn't expect its volume to change even after oven drying, and even after applying the load, the volume and weight of the solid will remain as it is. So this is after oven drying. So after oven drying, the weight of solid is 18 kilonewton. So this weight now became 18 kilonewton, and the initial weight will be 20 kilonewton when it is in natural state. So 20 kilonewton means it has a solid of weight 18 kilonewton and also water. So all this total will become 20. That means water has to be a 2 kilonewton. So water has to be 2 kilonewton, and the total volume is given. Yeah, total volume of wet soil is given here. It is a total volume of wet soil, which is 1 m cube. So this is total volume. It has 1 m cube. So from this you can easily calculate water content, right? Because water content from the classical definition is nothing but weight of the water divided by weight of the dry soil solid, which is here is 2 divided by 18, which is 1 by 9, which becomes 11.11 percentage. So first part of evaluating water content is over. So after evaluating water content, they asked about porosity, vibration, degree of saturation and all. So we'll go first of all by a classical definition of gamma bulk and then gamma dry. So first of all, from this, gamma bulk is nothing but the total weight. Total weight is 18 plus 2. 18 plus 2 is 20, which is how that was given, 20 kilonewton. So 20 kilonewton divided by 1 m cube. So gamma bulk is 20 kilonewton by 1. That means it's a 20 kilonewton per m cube. So after evaluating this gamma bulk, we'll use this basic formulation at what I have given it for your quick review, which is G 1 plus W divided by 1 plus E, right? So we'll use this formula, which is nothing but G plus W divided by 1 plus E. So yes, into absolutely gamma W. But see here in this problem, gamma W is not given. But while giving any competitive examination, if gamma W is not given, then you may assume it as 9.81 kilonewton per m cube. But if the gamma W is given, then you have to take whatever the given gamma W is in there. So we'll assume over here as 9.81 kilonewton, because in many times gamma W given may be 10 and you may take 9.81, you may get the different answer based on the different values of the gamma W. So therefore over here in this equation it becomes 20 equals to the G of soil solid is given it as 2.67, answer into 1 plus 0.11, that's what we have calculated water content just now, to 1 plus E into gamma W, which is 9.81, to place it over here, and from this expression we'll calculate E 0.455 or so you've calculated E, which is 0.455. So second case, that is void ratio relation is over. So in the next phase, while calculating the porosity, you need to use this relationship. 1 plus E becomes equals to 1 by 1 minus N. So you need to punch the value of E, which is 1.1 plus E, 1.455. And if you punch it in this equation, you'll get the value of N as 0.313. So yeah, right, you punch it, you will get it 0.313 porosity. After evaluating water content, the porosity, only the left out parameter is the degree of saturation. So this degree of saturation is nothing but volume of water to the volume of voids, right? So from this classical expression, ESR equals to water content into GS. Since the GS in the problem is given it as 2.67, becomes 0.11 into 2.67. E we have calculated it as in the last expression 0.455 into SR. So if you rearrange this, you'll get it SR equals to 0.6455. So therefore SR became 64.55%. 64.55. So this finishes your problem number 1.1, which is very quite easy. We'll go for the next problem, problem number 1.2. So the same problem, just here given water content of a saturated soil. So saturated soil wording is very important. Saturated soil meaning the degree of saturation is 100%. Specific gravity of soil solid is given it as 2.7. Water content given it as 30%. And here specifically it was mentioned you have to take gamma W as 10 kilonewton per m3. And what you are supposed to calculate is the gamma saturated and the void ratio of the soil. This is again going to be a easy question. Here water content is given it as 0.3 and the specific gravity of soil solid given it as 2.7, and also gamma W given it as 10 kilonewton per m3. So therefore here asked thing is gamma saturated and E. So again you need to use the same expression, gamma saturated equals to G plus E divided by 1 plus E into gamma W. Everything is given, but here E is missing, right? For E you need to again rely on this classical expression, E into SR becomes equal to W into G. Here the saturated soil is given. The saturated soil given, this means that the degree of saturation is 100%. Remember, saturated soil, that means degree of saturation is 100%. So if you place just SR 100%, that means 1, you'll get E equals to W into G. So this becomes, the W is given it as 0.3, answer into G is given it as 2.7, the E becomes 0.81. So you need to put this value of E in this expression in order to evaluate gamma saturated. So gamma saturated became 2.7 plus E value, that is 0.81, divided by 1 plus 0.81 into gamma W, which is 10. So the finally answer became 2.7 plus 0.81 divided by 1.81 into 10. So it became 19.3922 kilonewton per m cube gamma saturated is. Okay, fine. So this is a very simple problem. Again, same problem. Here the porosity was asked. Porosity of a soil, that means n value. In its natural state, the soil sample in its natural state has got a mass of 2.290 kg and volume 1.15 into 10 raised to minus 3 m cube. So that means the soil, if I draw just the three-phase diagram, solid, water and air interface, so the total weight, that means including water and solid, it is 2.290 kgs and the total volume is 1.15 into 10 raised to minus 3 m cube. And if I just oven dry the soil, then the water will be evaporated out and the solid will be weighing 2.035 kg, right? So the solid weight became 2.035 kgs. So therefore the weight of water which is present in the natural soil will become 2.29 minus 2.035 kg. So it became 2.29 minus 2.035 became 0.255 kgs. So therefore this is how the water content is determined. Water content means weight of water to the weight of dry soil solid. So it became 0.255 is the water amount divided by weight of dry solid, which is 2.035, and it became 2 divided by 0.035 becomes 12.5 percentage. You need to multiply by 100. This expression gives you 0.125. So you need to multiply by 100, which gives water content equals to 12.5%. And the asked thing is the porosity of the natural soil, that is N. So N can be determined after evaluating E, right? So, but here, if you use this expression of E into SR, which is equals to W into G, here water content you have evaluated currently. So water content is known to you. G is given, which has 2.65 is given, but SR is not given. Then you cannot calculate E because SR is not given. So for that, there is one more again way which gives you the relationship between bulk weight with reference to the water content and G and void ratio. That's what we have reviewed in the quick review session. This particular expression, this particular gamma bulk by gamma W becomes equal to G 1 plus W divided by 1 plus C. So again here in this expression, gamma W is not given, so but gamma bulk is given. gamma bulk, but again bring back the expression gamma bulk, that means the mass is given, not the unit weight. So anyhow you can determine it by just multiplying by value of g, which is 2.290 divided by this particular volume. So rather than gamma I will write, because it's the mass is given, rather than gamma I will write a rho, that is mass density. So here also I will write rho, here also I will write rho. So remember, rho of water at 4 degrees centigrade at this temperature, rho W is 1000 kg per m cube, and gamma W is 9.81 kilonewton per m cube, or this rho W equals to 1 gram per cc, gram per cubic centimeter, or also equal to 1 ton per meter cube. So also equals to 1 ton per m cube. So this gives you an fair idea of how to use this densities more effectively. So you need to remember this, all this 1000 kg per m cube, gamma W, rho W, gamma W 9.81 kilonewton, or in many cases it is 10 kilonewton per m cube, which is rho W 1 gram per cc, and also rho W equals to 1 ton per m cube. So here rho bulk is given, which is nothing but the weight, or sorry, mass divided by the volume. Mass is 2.290 divided by 1.15 volume into 10 raised to minus 3. So this became 2.29 divided by 1.15, it becomes equal to 1.9913 into 10 raised to 3 kg per m cube. So rho bulk at this expression becomes 1991.3 kg per m cube. So this value, rho bulk 1991.3 divided by rho W becomes equal to, so I will just put all this value, rho bulk, rho W, G given in the problem is 2.68, and water content, what we have evaluated earlier, is 12.5%. So G given it as 2.68 into 1 plus W we have evaluated 0.1. Remember here, do not place W in percentage, right? Do not place it in percentage, you need to place it like this in terms of the fraction 0.125, something like that. So divided by 1 plus E. So this expression is the value of 1 plus E, which is 2.68 into 1.125 divided by 1.9913, which gives direct value of 1.5141. So this gives you E of 0.5141. So once E is known to you, you can calculate N, that is porosity, from the standard formulae. So it just becomes, porosity became equals to 0.34. Let me check with the answers. Yeah, right, 0.34 is the right answer. This is porosity. So this finishes your level 3 problems. We'll go for level 2 problems shortly. Thank you.